I would be really excited to help you guys get into some analysis and work on that with you. I'm super excited about the predictive processing project personally, so I think there's a lot of opportunities and avenues to explore. Ignore that it says confidential down there. That's an error. I'm not spilling any secrets here. Okay, I will be talking more about the predictive processing project tomorrow and going in detail showing those notebooks off tomorrow. Today, I will be mostly talking about the OpenScope DataBook. So as Jerome discussed, we've been doing the project OpenScope for the last 4 or 5 years. And when I joined the OpenScope project, basically the state of the field was that NWBs were very new. Not many people were using them. We had already started pushing some of our data into NWB early on. And at the time, there's obviously many different kinds of analyses, and most labs are doing a lot of the same kinds of analyses. But of course, without a common file standard, it was useless for them to share those or share the code as much. And so now there's this sort of floodgate open where we have the opportunity to take these NWB files and then create reproducible and replicable analyses on them. And at the time, there wasn't really any centralized repository for this code. And if there was, it was really hard to sort of access and use the data. And they certainly weren't pulling data directly off of DANDI. Of course, AI tools they didn't exist yet either. So code was hard to come by. And it would take a lot of time and effort if you wanted to produce code to analyze someone else's data sets. So we set out to achieve some of these goals. Specifically, we wanted people to be able to reproduce analyses. They could either alter and tweak analyses on a data set, or they could plug in a different data set and do the same analysis to compare and contrast. And we wanted them to be able to do it with just a push of one button or two very, very easily. We wanted the code to be well documented. We wanted the projects to be well documented and actually educate users as well. So we didn't just want it to be an analysis tool to analyze existing data, but we also wanted to serve as an educational resource, which is why Ben earlier described it as a textbook. So we kind of aimed for that, a compromise between both of those. And then finally, when you do your analysis, you produce figures. We wanted to be able to easily share, generate those figures, regenerate them. Ultimately, this would help and promote the proliferation and usability of our data. Because we knew that OpenScope, we had a mission of open science, but we knew that just providing the data wasn't sufficient, because I'm sure all of you guys have tried to use data from other labs and found it very difficult and challenging, especially when you don't know all the context behind the experiment, and maybe if you're unfamiliar with the formats. So how do we do this? The OpenScope DataBook, it's just a repository of Jupyter notebooks. It's basically a website. It contains Markdown, chapters. It's powered by Mist behind the scenes, and it's hosted for free on GitHub Pages. And then you can run the notebooks, and they run from files directly on DANDI. So like I said, you could plug in something else from an Allen Institute dataset, and in general, it would work. Also, the notebooks are launchable on several compute platforms. Namely, this would be Google Colab these days, because like Ben talked about, DANDI Hub will be sunset on August 1st. But you could still launch it to DANDI Hub until then. The content is expansive, and it's still growing. I produced maybe half or 2/3 of the notebooks to try to cover a lot of common analyses, but we also have notebooks contributed from other people at external labs, showing off models that they're more familiar with or that they want to produce a lot of excitement about. So for instance, we have one showing off Zebra from the Mackenzie Mathis lab. Camilla produced a notebook describing her project from the Flatiron Institute. And we're always adding stuff and taking contributions. Okay, so accessing the data, you guys already know. It's on DANDI. You can stream it, you can download it. Almost all the data sets are public now, but there's a handful of embargoed ones still. And you could access those ones if you have privileged access with the DANDI API key. So for now, that's just me. Okay, so I'm actually just going to take a while to demonstrate it instead of talking more and more about it. So if you just Google OpenScope DataBook, here is the actual website, but for now I'll go to the GitHub pages, or the GitHub page, excuse me. You can see the repo here. We have issues from the community. We take pull requests in case people want to adjust the notebook or provide feedback or add in their own notebook. It's a citable resource, it's a citable DOI on Zenodo. Let's see, there's some instructions for setting up, which I will kind of go into later. And then here's the table of contents. And like I said, we're always accepting contributions from other people. If you click on this link, you can go to the actual databook. So here's the actual databook. You can see a nice view of all of our contributors here. And it includes tons of metadata about them. And you can see these chapters here on the side. So this basics chapter is stuff you guys have already been thoroughly educated about today, just like opening an NWB file, accessing it. So you can use that as a reference if you forget. Visualizing, this is kind of more of an educational resource if you are not a neuroscientist or if you are trying to explore like a modality that you're less familiar with. So if you're interested in exploring 2P, two-photon data, then this would help you explain some of that for you, and you could explore it with our Allen datasets. And then we have these two analysis chapters. So first order analysis, which is just more basic stuff that you might want to do, like receptive fields, and then more advanced stuff like I mentioned CBER earlier, GLMs. And then finally, we have this big chapter here of OpenScope experimental projects. So if you're interested in any of our experimental projects, this is, I would say, your one-stop shop to start getting into the data. It'll help you open the data, it'll help you pull out all the fields you need, and it'll explain the context behind the experiment and what everything in there means. So let's see. Like I mentioned, you can launch them on Google Colab. So I'll just show, so for instance, if you go to this receptive field notebook here, you can see all the plots that have already been generated, but you could press this little badge here to launch it in Google Colab. I've already done this. And a little bit of a note about running on Google Colab is the environment. Google Colab doesn't automatically set up the environment for you. So we have this little cell to set it up. And specifically in Google Colab, you have to run this, and then the changes to the environment don't take effect until you rerun the notebook. So you have to run it, and then it will say the kernel crashed or ended, basically, and then you have to rerun it. So I've done that. It downloaded the NWB. It shows you all the important fields in here. You can change which stimulus you're interested in here. For the receptive fields, it would be the Gabors. You can change the criteria by which you select certain neurons. So it chose them based on the signal-to-noise ratio and the firing rate, but you could also adapt it to select units from one region, for instance. And then it actually, basically does the analysis on the responses, it gets the vectorized receptive field, and produces this nice plot. So ostensibly, you could, like I said, you could plug in any of our OpenScope data sets and do the same thing right away with minimal changes. Actually, I'll show you this on DANDI here. So if you just search, someone asked earlier about looking at our data sets. If you just search OpenScope, you'll see all of them. These ones, they're drafts, but these are fully public. I think, yeah, this is where you'll find all of them. There's, I think, 10 data sets that are on here that are unembargoed. These are the two predictive processing ones. This is the psilocybin one Jerome mentioned. And we have illusion over here, somewhere around here, yeah. So go ahead, take a look at these. Let's see. Tomorrow, I will, like I said, I'll go in more detail. I'll actually specifically go through the predictive processing, mesoscope, and neuropixels data sets, and I'll explain more about how to use those files. Okay, now I want to take a little digression into talking about UV. This is kind of separate, but I think it will be really useful for some of you guys who use Python a lot. And then I'll wrap it up by showing you how UV makes using the databook super, super easy. So just by a show of hands, how many of you guys are familiar with UV? Okay, that's good. That's more than I expected. If you are a frequent Python user and you do not use UV, then I think this will be life-changing for you. So I prepared a little bit of a demo. Let's see. Yeah. Totally different. Totally different. Yeah. So I'll just start by telling you why I moved to UV. So basically, UV is a it is a tool coded in Rust that is built upon Python virtual environments. So it's a layer on top of Python virtual environments. So natively Python allows you to make a folder, which is basically an environment that contains site packages that you might want to be self-contained without interfering with your system's site packages, your system's dependencies. And this could be like if your system is Python 3.10, you can make a virtual environment that's 3.13, for instance. And when you have many, many dependencies, making changes to one dependency tends to break a lot of things, and pip, Python's native installer, is not very good at helping you resolve them. It's pretty bad, I think. And with the DataBook, actually, I used to have this slide here talking about the key challenges for the DataBook because this was the #1 difficulty with getting the DataBook working. I spent countless days and hours fixing these problems so that users didn't have to handle environment challenges. But UV makes that really, really easy. So basically what it does is, I made this little demo here. I downloaded an NWB sample this morning from DANDI. I made this little script which just opens the NWB and then plots. Yeah. Oh, of course. All right, can you guys see this? Okay. This file just opens an NWB and pulls out some data and generates basic plots. So if I were just to run this in Python, it's going to fail because I don't have matplotlib installed, and for that matter, I have a different Python version too, which might cause issues. So I created my little pyproject.toml here, just specifying the dependencies I want for my project. And then let's see, the first thing you would want to do, actually, let me just explain how to download UV if you guys want to follow along here. It's really, really quick. I don't expect you guys to follow along, but if you want to, you basically run one of these commands here depending on your system. I've already done that. It just runs and then installs immediately. Okay, so assuming you have it installed, those of you who are installing, you might want to, I think you need to reset your terminal or restart it to get it to work. But assuming you've done that, basically the first thing you can do is run UV lock, which basically takes your pyproject.toml. This is like the human readable, human written like endpoint for UV. And what it will do is it will take your toml file that specifies your versions, and it will generate this UV lock file. This is basically UV's like intermediate that has all the really important versioning dependency metadata for everything that your project would need. And it's kind of the shippable part of UV that you could send to someone else if they wanted to reproduce your environment. And then with that, let's see, you can run UV sync. And so what that will do is it will generate your Python virtual environment from the UV lock file. And actually, it will also regenerate the UV lock file first. And then it'll generate your virtual environment. And because it's written in Rust, it's super darn fast. On pip, that would take who knows how long. Okay, so it'll do that. And you could, let's see, it generates your virtual environment. And you can normally, for any Python virtual environment, not just UV, you could just activate it basically by going into, this is how just you would normally do it. And that activates the environment, and then any Python code you run here will basically be with the right code. So if I run this, it should take just a moment to execute. Or maybe 2 moments. Okay, great. It just spits out this little figure. Yeah, so you could activate it like that, or my favorite personally is you can just use UV run and then type in the command you want to do, and that will just create this ephemeral environment that it will spin it up and then run it and then end it. So that's super useful. Behind the scenes, I think UV does something a little bit more efficient than Python virtual environments. I think it kind of caches certain dependencies, and so if multiple projects behind the scenes are using the same, I think it uses just one install of both, so it's more efficient. And like I said, it's also much faster. And then the thing that really shines over pip is, for instance, if I were to do this, if I decided I wanted to use an older NumPy, and then I run UV sync. Oh, that's not right. Oh, that's because there we go. If I want to use so normally it resolved that to a newer NumPy because it realizes that an older NumPy is not compatible. But if I try to enforce this NumPy 1.24, instead of just telling me there's like some kind of error, I think it does a lot better job telling you exactly why this failed and what the incompatibilities are, and it kind of implies what kind of fixes you can make. And especially if you combine this with using like Claude or whatever your typical workflow is, it's made resolving dependency conflicts much, much quicker for me. Like I said, with the OpenScope DataBook, we have dozens of dependencies, and that would be just a nightmare to try to fix and figure out the exact combination that works. But with UV and your AI agent, it's super, super useful and much quicker. So I can put this back and I can sync again, and then it will work. So if you want to do this with the DataBook, I guess you could, let me show you how to you can git clone it here. I already have this installed, so I'll just do this in my demo folder. This is going to take 2 minutes or so. Actually, let's see.